Okay, today we are starting chapter 4, graphing and writing linear equations. All right, so there's some terms you need to know, just getting started. All right, the first one you need to know is that a linear equation is an equation whose graph is a line. It's a straight line. That's what it means by linear equation. All right, so that's kind of where that comes from. Any point on that line is a solution to the equation. So you're going to see what we're talking about here in just a second. But this is really important. Make sure you get this written down. Slope-intercept form, y equals mx plus b, is really the foundation for this entire chapter. We're going to use this formula so much and look at all the different ways that we can manipulate the formula and use it to solve and graph. All right, and the other term for this is called function form. So basically it means the same thing. If I say function form, I mean y equals mx plus b. All right, so in example 1, we are coming up with values to basically plug in to this function right here that you see. All right, we know that it's a function because y is by itself on one side of the equation, so that's an important part to this, okay? Now, look at what some of the notes I made up here, all right? This is really important when it comes to choosing which values you're going to graph with. You're going to make them up, all right? You can choose any number you want, but why wouldn't you choose 52 or 55 or 60? Well, that's because you don't want to graph that big. So basically, the rules I'm going to give you are you need a negative number, you need a positive number, and 0 is always a good number to use, okay, because it's just easy to plug in. And you take each one of these values and you plug it in for x into the function, all right? So in this block, we say y equals 2 times negative 1 plus 1. We're just plugging in the value, again, that we could have used any value, but we want to keep them small. All right, 2 times negative 1 is negative 2, plus 1 is negative 1. So now I have an x value and I have a y value, and I'm going to put them together as an ordered pair. All right, we'll talk about the ordered pairs in a second. Okay, now I want you to go ahead and make the substitution on the second one. All right, you should have done 2 times 0 now plus 1. Well, 2 times 0 is 0, plus 1 is positive 1. So now our ordered pair is 0, 1, 0, 1. And we do the same thing with the last one. Y equals 2 times 2 plus 1. And that is 5. So now we have 2, 5. Okay, now these ordered pairs are what we're now going to take and we're going to graph, okay? So I want you to get out a sheet of graph paper, okay? So it's important for us to practice at least a couple of these. Go ahead and get out a sheet of graph paper, and we're going to graph this linear equation. Okay, so I'm just over here now setting up my graph, and hopefully you are setting up your graphs. For each grid line, you should have a point. Okay, so you have 1, 2, 3, 4, and 5. Negative 1, negative 2, 3, 4, and 5. Negative 2, 3, and 4. All right, just numbering our graphs is what you should be doing. Okay, and I think we're going to do 3 of these today. All right, so keep that graph paper handy. So now we're going to plot our ordered pairs. Our first one was negative 1, negative 1, right here. Our second one was 0, 1, and our third point was 2, 5. All right, and what's really nice about these linear equations is that it always forms a straight line. Okay, and just like we said on the terms slide, basically any point that lies on this line is actually a solution. So what I mean by that is, you see how the line intersects right here at a point of 1, 3? Well, if you were to go back to that function and plug in 1 and 3, it would actually be a solution also. So the line represents all of the possible solutions. We just put 3 of the solutions on the graph. But there's really actually an infinite number of solutions. All right, and they lie on the line. Okay, so let's do another one. Okay, all I did was change the function. Now it's y equals 3x. I want you to take a minute and go ahead and do your substitutions. Okay, did you do y equals 3 times negative 1? We're just plugging in our values in for x. Y equals 3 times 0, and y equals 3 times 2. Okay, and we get negative 3, 0, and 6. And now we're going to make our ordered pairs. Negative 1, negative 3. 0, 0, that one's easy enough, and 2, 6. Okay, now I want you to go over to your graph paper, set up a separate graph, and I want you to graph this equation. All right, so hopefully you have your graph set up now. Okay, and now we're just going to plot the points. Negative 1, negative 3. Let's see, and then we have 0, 0. And then we have 2, 6, so that one's going to be all the way up here. Okay, and now we're just going to draw our straight line through all the points. All right, arrows on both ends of the line show that our solutions are infinite, and we have now officially graphed our linear equation. All right, so now in example 2, we're graphing what we call horizontal lines. So what we see here is just a y value. That's all we have here is just a y value. So I want you to now set up one last graph. We're actually going to graph 2 different lines on this last graph, but go ahead and set another graph up on your graph papers. Okay, so what we see here, when y equals negative 3, I'm going to go down to a y value of negative 3 and plot my point. Go ahead and do that. And when that happens, it forms basically a horizontal line that would run straight through that point. Okay, so y values are going to be a horizontal line. All right, and you just plot it wherever that value is, that's where you plot the point. And that's all you have to do for that. And if it's a vertical line, so you can do this on the same graph. If it's a vertical line, you just go to the x value of 2. And you draw your line through the point. And now you've graphed your vertical line. All right, so anytime you're just given an x value or just given a y value, you need to just plot the point, and then you draw the line in the opposite direction of the axis. So because the x-axis goes left and right, I plot the point and I draw the line vertically. Okay, so last example. Oh, I lied. We have one more graph, sorry. Okay, we'll have to set up one last graph. We actually are doing 2 of these, but I won't make you graph both. All right, so one more graph and then we're done. All right, but before we graph it, we first have to get this equation in what we call function form. And we've actually been doing this since chapter 1. I keep putting it on your test. So this is something and a concept that you have reviewed, all right, since we learned it back in August. But we have to solve for y. Y needs to be by itself on one side of the equation. So I have the equation 5x plus 2y equals 4 I need to isolate y. So I need to move my 5x term first. Subtract 5x. All right, we want to subtract 5x from both sides. But remember, we cannot combine these terms. Okay, they are not like terms. And according to function form, my x term needs to come first. And we're going to learn more about what these variables stand for later in the chapter. All right, but for now, all we need to know is 2y equals, and our x term comes first, and then our number by itself. All right, and what do you do now? What do you think? All right, if you said divide everything by 2, you're exactly right. Okay, and now we have y equals negative 5 over 2 x plus 2. All right, and that's our equation. All right, so now that I have y equals negative 5 over 2 x plus 2, I'm going to go ahead and rewrite that. Y equals negative 5 over 2 x plus 2. Now I need a table, okay? So in order to graph, I need a table of at least 3 values. So I'm basically doing now what I did in example 1, all right? And there's just going to be one small change that I'm going to make. Okay, so here's my x values. I've got to pick which values I want to use for x. And then I substitute. Okay, and then I get my y values. All right, so my function is y equals negative 5 over 2 x plus 2. Well, is there anything that you notice that's different about this function versus the other functions that we've solved? All right, so if you're thinking there's a fraction connected to x, you're exactly right. And we don't want to graph fractions. If we can avoid it at all, we want whole numbers, okay? So instead of using our standard negative 1, 0, and 2, let's be a little more mindful of maybe a number that I can multiply negative 5 over 2 times in order to get that fraction to cancel. And here's how I know what it's going to be. I look at the number in the denominator, and I choose x values that are multiples of that number, okay? So again, I still have to have a negative number, so why not choose negative 2? Now my 2's are going to cross cancel. 0 is still fine, and then let's do a positive 2. All right, so now I have y equals negative 5 over 2 times 2 over 1, or I'm sorry, negative 2 over 1 plus 2. All right, and this is something that you can do in your calculator if you want, but I mean, you know that those cross cancel and that becomes a negative 1. Negative 5 times negative 1 is positive 5 plus 2 is 7. All right, and then this one's going to be easy. Y equals negative 5 over 2 times 0 plus 2. Well, anything times 0 is 0, so that one's just going to be 2. And y equals negative 5 over 2 times 2 over 1 plus 2. And now those are going to cancel down just 1, so it's going to be negative 5 plus 2 is negative 3. And now we're ready to graph. Okay, so we just match up our ordered pairs, just like we've done before. So now we have negative 2, 7, 0, 2, and 2, negative 3. And we're just going to plot our points. All right, so negative 2, up 7. All right, you should be graphing this on your graph paper. 0, up 2, and 2, down 3. And again, there's your straight line. Straight line all the way through. And you have graphed your linear equation. Okay, so we had to get it in function form, then we had to make our table, then we graphed. That's all the concepts now coming together. All right, so I want to practice one more problem. I'm not going to make you graph it. I'm just going to show you the graph. but I want you to first rewrite this equation in function form. Go ahead and do that. Okay, did you subtract 9x first from both sides? Remember, you cannot combine those terms, so now it's 3y equals negative 9x plus 15. And now divide everything by 3. And y equals negative 3x plus 5, okay? So now that it's in function form, you can set up your table. All right, so let's do that. All right, let's go ahead and rewrite this, negative 3x plus 5, and let's set up our table. Remember, you need 3 values. You need 3 x values, and you can make up whatever numbers you want, but unless there's a fraction, I really want to stay consistent and just using the same numbers, okay? Again, we don't want to use huge numbers because we have to graph it. All right, so we've got our x value and our substitution and then our y value. Okay, so we're just going to use our standard set of numbers, negative 1, 0, and 2. And we're going to plug it into our function, y equals negative 3x plus 5. And y equals negative 3 times negative 1 plus 5. Make all our substitutions. Y equals, well, we know that's going to be 0 plus 5. And y equals negative 3 times 2 plus 5. All right, well, negative 3 times negative 1 is positive 3 plus 5 is 8. And 0 plus 5 is 5. And negative 6 plus 5 is negative 1. And now we're ready to graph. Again, you don't have to graph this, but we're just, hopefully you set up that table before I put it up there, but basically we're just practicing this concept of getting it in function form and then coming up with our table. Why did we do the table? So we can match up these ordered pairs. Negative 1 up 8. 0 up 5. This is a pretty steep slope. And then 2, negative 1. All right, and we draw our line. And we have officially graphed a linear equation. So lots of graphing today. You can definitely expect that on your next quiz. And if you understand that, that's everything you need to know for section 4.1.